We're talking engineering assessments, failure investigations, even plans to bring pipelines that have been shut down back online. The core of it is, how are these companies making sure these pipelines are safe and reliable?
It's pretty fascinating stuff when you get into it. What jumps out at me is just how in-depth these reports get. You can see the thought process, the testing, the preventative measures they're putting in place. And it all comes back to understanding risk, what are the potential problems, and how do we minimize those problems?
Okay, so let's jump into a specific case. The report zeroes in on pipeline at their Boundary Lake unit, accelerated internal corrosion. And get this, they say it was triggered by, quote, detrimental upstream startup behavior. That sounds pretty specific.
Yeah, and that really highlights a key vulnerability. Something happening upstream from the pipeline can have a big impact, even if it seems unrelated. In this case, the way they started up a well seems to have introduced a bunch of gunk into the pipeline. Biomass, sludge, debris, and that basically created a fast track for corrosion. What's wild is that this pipeline was built way back in 1986, been operating for almost 40 years. They even say this corrosion was, quote, unforeseen based on historical performance. Makes you think, were there any early warning signs they might have missed, even with all that data? They've got a multi-pronged approach, which is pretty standard in these situations. They're considering a full inline inspection, an ILI, within the next year, if they can find a tool compatible with this particular pipeline.
So they're not just fixing the immediate problem. They're thinking about preventing similar issues elsewhere in their system, right?
Big focus on prevention for future well startups. They're going to implement these high-rate water purges right after a well comes online.
They're getting to the root of the problem, not just putting a Band-Aid on it. The report mentions that this whole issue of accelerated corrosion from these liquid surges is becoming a bigger problem all over the Western Canada's sedimentary basin.
It's becoming a real headache for the industry. These sudden surges of liquid are a major cause of internal failures, and they suggest that traditional long-term corrosion prevention might not cut it when you have this kind of rapid, localized damage from all this debris.
Okay, let's switch gears a bit. A very different type of reactivation. This one was abandoned back in 2015.
Yeah, and what's interesting here is that they didn't abandon it because of any integrity concerns. Wants to bring it back online, and the way they're doing it is pretty cool. They're going to install a brand new freestanding spooled composite liner inside the existing steel pipeline. Basically, this liner becomes the new pipeline for the natural gas.
They're putting a new pipe inside the old one, and this new inner pipe is handling the gas flow.
That's it. This composite liner has its own pressure containment, plus it's naturally resistant to corrosion. So they're not relying on the old steel pipe for anything except as a protective shell for this new corrosion-proof inner pipe.
That's a clever way to extend the life of existing infrastructure. Spooled composite pipelines have a good track record in natural gas service.
The report mentions the low failure rates for spooled composite pipelines used for natural gas. It's because they experience lower mechanical stress than in other applications, and they're not exposed to extreme temperature swings with natural gas. It's a great example of using new technology to solve old problems.
Okay, last but not least, we have a report about reactivating an abandoned pipeline in the Whitecourt field. It was used for fuel gas, and it's made of HDPE, which is high-density polyethylene plastic. It's another example of bringing a pipeline back into service.
This pipeline was built in 2004 and abandoned in 2015. The interesting thing here is that HDPE material, it's naturally resistant to corrosion, which eliminates a lot of the worries we have with steel pipelines.
Corrosion is basically a non-issue with HDPE.
They didn't abandon this pipeline because of integrity issues. They did have one weld failure during construction, but they consider that a one-off event. Their overall risk classification for damage and failure on this reactivated pipeline is low.
Bringing this HDPE pipeline back online is probably a lot simpler than those steel pipelines we talked about.
They'll do a hydrostatic test before they put it back into service, but their ongoing monitoring plan is just routine visual checks. It's HDPE, it's carrying fuel gas, no H2S or other corrosive stuff, so the long-term integrity risks are pretty minimal. It goes to show how the material of the pipeline can dramatically change the whole integrity management strategy.
Okay, so we've covered a lot of ground here. We've got a failure investigation, 2 reactivations, and a request to change operating parameters. What are some of the big picture takeaways for you from all these reports?
I think the most important takeaway is that the industry is getting really good at managing pipeline integrity, whether it's thoroughly investigating a failure to find the root cause, coming up with innovative ways to reactivate old pipelines, or rigorously justifying any changes to how a pipeline operates. There's a clear focus on safety and risk mitigation. These reports emphasize how crucial it is to consider the properties of the material, the potential for both internal and external corrosion, and things happening upstream.
The role of technology is huge here. We're talking about those inline inspection tools that can spot tiny flaws. And these sophisticated risk management systems like TRIAGE by AbaData that give operators a complete picture of their entire pipeline network.
These technologies are giving operators the data and insights they need to make smart decisions about maintenance, repairs, and operating conditions. The consistent use of things like pigging, corrosion inhibitors, cathodic protection, and advanced risk assessment platforms points to a data-driven approach to safety and reliability.
Thanks for joining us for this deep dive.